Okay, we are asked to find the partial fraction decomposition for this rational expression. And this is much like we've been doing in the past, only now you'll notice we have an x squared in the bottom. Then it's going to change what we do slightly. So we start out with dividing it up just like before. This is 7 or 17? 7, okay. Just double checking. For some reason I thought it was 17. I thought I better check before I get all the way to the end and realize I had the problem written down wrong. None of us have ever done that, right? So this is A, but now this here, instead of being just B, is going to be bx plus c. And anytime you have an x squared in the bottom, you're going to have to do this, and where you add in an x in the numerator, and it's going to make it a little bit more complicated. And this whole thing is going to equal, if this will let me, obviously work here, equals 2x minus 1 all over everything. And then just like before, we're going to start by timesing by the denominator. So I'm left with A times 5x plus 7 plus this bx plus c times x plus 4 equals 2x minus 1. Now what I am going to do, though, is I am going to completely leave this side alone for right now, and I'm just going to simplify the other side. And you're going to see why here and how I'm going to do this. It's a cool little trick. So I have 5a x squared plus 7a, plus here I have bx squared plus cx plus 4bx plus 4c. So first enters the outers. I'm double checking here because I've got, obviously, with all these letters going everywhere, plus this. I ran out of room, but that's okay. Okay, now what I'm going to do is I'm going to consolidate. I want each variable of x together. So I have 5a plus b x squared. So I put those together. And then I have, you can see I have c plus 4b x, so those are those two, plus 7a plus 4c. Okay, and this all again equals 2x minus 1. I'm going to put this down here because I'm going to need it here in a minute. So now what I'm going to do is I'm going to create a system of equations. How I'm going to do that is, what's my x squared term? Well, I don't have one, so 5a plus b equals 0. Then here, c plus 4b equals 2. I'm just matching coefficients. So 7a plus 4c has to equal negative 1. So now what have I created is a system of 3 equations with my 3 variables. And we learned how to solve this earlier. Now I can just solve this as I would solve any system. And so I'm going to start out here by doing this. So I have 5a equals negative b. That then is going to allow me to put that, you can see both of these are in terms of c, so a c in both. So if I change this a to a negative b, or I change this b, in any case, I can then match. So I'm going to do that. So I'm going to do, I know what, I'm going to actually change this to make myself a little less likely to screw up a sign. I have 5a equals, negative 5a equals b. Okay, so I have c plus 4, 5a equals 2. So then that gives me c minus 20a equals 2. So then that means reordering this, tc plus 7a equals negative 1. And then these are my regular system. I'm actually going to solve this. So this is plus 20a. So I have 2 plus 20a plus 7a equals negative 1. Then 8 plus 80a plus 7a equals negative 1. So then this gives me 87a equals negative 9. So a equals negative 9 over 87. So I move the 8 over there, and hopefully that's clear. So now this is A, and I'm going to write myself a note over here. And now I need to go back up to my original three equations, which were here, and I need to find B and C. So now this was, I just found A. So if I do 5 9/87 equals negative B, so that means that this is 45/87 equals B. Yay! So 45/87, this is B. Now I just need to find C. So you can see this is just mainly messy. So what I'm going to do is I'm going to take this, I need C. So I have C plus 4B, so I have C plus 4B equals what? C plus 4B equals 2. Okay, so 4 and B was 45/87. So 45 times 4, no, that's not the right, is 180. So I have C plus 180/87 equals 2. So 2 minus 180/87, put that back in fractions, C equals negative 229. Okay, and going back, remember our other fractions, just to do this, I can reduce them. So 9 goes into 87, so 87 you can take 3 into, so A becomes negative 3/29. And let's see here, 45, I can do 3, so 15/29. So let's write this down. We have to do some simplification here, and you always want to check. So my A is negative 3/29, B is 15/29, and C is negative 2/29. Now I'm going to have to go put this all back in my equation. So this means that A is, but then remember this was B plus C, so my BX plus C is 15/29x minus 2/29. So let's remember all this. Now to put this all back together, what am I going to do? Well, I have A, which was my negative 3 over, and what was my original equation here on the bottom? X plus 4 times the 29, plus now here, this 15x minus 2 goes in the bottom, the 29 goes down here, and what was my bottom? My bottom was 5x plus 7. 5x squared plus 7. So this is my answer. So let's go back here, and hopefully I can get this all into here without screwing it up. This is the most complicated part of the entire thing, obviously, getting it all into here. Let's see here, 3. Actually, hold on a second. Okay, I decided to just not make you watch me try to put that all in. Plus, by pausing it for a minute, I was able to switch from the tablet form to my regular laptop. It's a lot faster with the keyboard to type it in. But you can see, once I got this whole mess in here, the answer is right. So anytime you have a quadratic, the main thing that's going to change is obviously it's going to take a little bit longer. It's quite the big mess here. But what matters is here in the setup, anytime you have an x squared in the denominator, you put this form in the numerator. Instead of just our one variable, we're going to have the bx plus c or dx plus e, whatever you want to call it. The point is you're going to have the x plus the constant, and that's what's going to change here. So these are long processes, but as I said, these are something that are being very useful later as a skill we need. So it's important, and the big thing here is obviously it's really hard for me to show you as I'm scribbling here on the tablet. But the big thing is obviously keeping track of your numbers, neatness, making sure that you know where all the numbers are. Take lots of space. This takes you 3 pages to do. That's okay. It might take you 3 pages to do all the arithmetic involved in this, because the numbers can get quite messy as you're trying to solve for all these. And as you can see, once we got down there, I ended up with a system of equations. And so this is going to be a multi-step process, and there's going to be lots of room for small errors. So really watch yourself, because there's nothing more frustrating than get to the end and you can't put in the answer, you click through it, math, language, and you're like 2 off, and you go back and look and you realize you flipped a sign. So, my biggest recommendation to you is take lots of space, lots of room, and neatness does count. And obviously, you know, it's really hard for me to show you that on the tablet where my handwriting is messier because I'm writing on the tablet and I don't have the same amount of space I do on my notebook. But if you saw my notebook page of these, you'll see they're very neat.